Geometry Air Test released items, and I'll just kind of go through each one. So anytime they give you some information, I really think drawing a picture is important. So as soon as they said that triangle XYZ is inscribed in a circle, I drew a circle and I put 3 points X, Z, and Y on there, and they did tell us that XY is the diameter, so I labeled that here, and then I randomly just put Z on the circle. We do know that when you have a diameter and you connect that to any point on a circle, this guy will always be 90 degrees, for sure, okay? We know that as a fact. We don't have to go through it, but the diameter, we know that this arc here is 180 degrees, and that this inscribed angle has to be half of that, so it always has to be 90. So once we know that's 90 and this is 30 and this is 16, we can use the Pythagorean theorem to find the missing side. The missing side is the diameter, and the diameter is the hypotenuse. Again, this is a combination of kind of circle properties and Pythagorean theorem. 33, we do know that the triangle sum theorem says that if you add up all three angles in a triangle, we always get 180. So when you look at angle B, you can use these two angles to find angle B to be 95. But once you know B is 95, you know that the two triangles have 35 and 95 and 35 and 95. That means that the two triangles, you know those two angles are the same, but then you also know that this 14, well, if that's 95 and that's 95, that has to be 50. Once you know that angle, that side, and that angle, well, you have angle, side, angle. And the other triangle has the same angle, side, angle. So we know that if we know angle F is 50, then we know the triangles are congruent by angle, side, angle. This is a reminder. These are the 5 ways to prove triangles are congruent. Side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse, leg. If you have those two, if you have any of those 5 for 2 separate triangles, that's enough to know the triangles are congruent. Reminder, side, side, angle, and angle, angle, angle cannot prove congruence. Angle, 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 actually just angle, angle proves similarity. 2 triangles are similar if you have 2 angles that are the same, because of course then the third angle has to be the same, but they can't prove congruence. Okay, 35. Okay, we're going to take this line here and we're going to rotate it about the x-axis, which is the horizontal axis. So this is me taking this and going like, whoo, 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 whoo. I'm taking these points and I'm rotating it about that line, and it'll actually form this cone shape thing. But it's not a full-blown cone, because this top, when you rotate it, that was not very effective. It would look like this, right? It'll have actually a hole in it. So this top thing is going to have a hole. And so it's going to look like more like a lampshade. And then if you just rotate it around, it'll look like that. Okay, triangle MKL is similar to triangle MNO. Just remember, if they're similar, that means that they have the same 3 angles and the sides are proportional. We also know that it matches up. So if you look at like K, it matches up with N. So angle K and angle N are the same, which is why I labeled them the same. So if you know that the sine of angle MKL is really just angle K. If you know the sine of that angle is 0.8, well then you know the sine of angle N is 0.8. And so think about that triangle now of sine of this angle. Sine is opposite over hypotenuse. So sine of this angle is x over 15, which is where this guy came from. They tell us that sine of the angle is 0.8. So I just take this 0.8 and I put it in here. And so you get 0.8 equals x over 15. And I just solved, right? You just multiply by 15. This is kind of like a construction. So you would kind of put your compass here and here and then make a tick mark, and you would know then your compass is exactly that long. And then you could put a dot here and go and make a tick mark, tick mark, tick mark, tick mark, tick mark, and then connect the 6 tick marks. Again, it says it's a hexagon, and so it's 6 sides, right? Remember, the tick marks are you showing them that you know how to make a construction. We know that if you take a quadrilateral and you put it inscribed in a circle, meaning inside of a circle, opposite angles are always going to be supplements. So angle S and angle Q are going to be supplements, which means they add up to 180. Angle R and angle T are going to be supplements. This one's fairly long, right? They give you the coordinates of some triangle, P, Q, and R, and I always say draw a picture. And so I just kind of drew a kind of a grid over here. It didn't have to be perfect. And I plotted P, Q, and R. And then if you want to find lengths, remember we're always using the Pythagorean theorem. So if you're at P, you go 8 up and 6 over. If you're at Q, you go 6 over and 8 down to R. And so both of these lengths are the same because they're both 6 by 8. And I did show that, but 6 squared plus 8 squared equals x squared. We know that the 6, 8, 10 triangle is a nice easy one. So that means that this is 10 and this is 10. And P to R is flat. It's just straight across. And you go from -4 to 8, right? That's just going 12 over. And then the perimeter of that guy is going to be the 10 plus the 10 plus the 12. And so you get 32. For 20, okay, so this is a big concept, right? We have to understand scale factor is how you make similar figures, is what you do when you dilate something, right? You take a triangle or a rectangle or whatever and you scale it by 2, which means you multiply all the sides by 2 or 3 or 4. But you have to imagine the area doesn't just get 2 times bigger, or in this case, it doesn't get 4 times bigger. The scale factor is 4. That means the area got 16 times bigger. Think about that. If I think about a rectangle and I make each side of the rectangle, I start out with my rectangle. This is not going to let me do it here. If I start out with my rectangle is like 3 by 4, and I multiply each one of those by 4, now it's 12 by 16. I made the area way bigger than 4, and it turns out the area ratio is always the scale factor squared. The volume ratio, considering you're multiplying each one of the 3 things by 4, would be the scale factor cubed. So once you know you have a scale factor of 4, square it to figure out how much the area would be bigger by, and cube it to figure out how much the volume would be bigger by if it was a 3-dimensional figure. So to find the area of the bigger triangle, we're going to multiply, and we're going to multiply by 16, and then 24 times 16 is 384. Again, another picture. It says it's a rectangle, so I plotted 0, 5, 3, 1, 3, -1, and 3, -4, and we know it has to be a rectangle. So all of these things, down 3 over 6, down 3 over 6, it has to be right there. And so what I did was, it wants the x coordinate, so I have to go over 6. So over 6 from 0 just puts you at -6. Again, it has to be the same length and parallel to the other side. So once you know this guy goes down 3 over 6, this has to go down 3 over 6. It has to be the same proportion, the same slope, same everything for a rectangle. And you can kind of make it make sense. And the y coordinate, they do tell you is 2, but so you know that. But it was the same thing. Go down 3 from 5 and you do get to 2. Draw a picture and help you out. And you do have a grid paper, so you can always draw these perfectly on a grid and kind of just eyeball it even. Okay, this is trig. This is just me reminding you that we know that SOHCAHTOA is true. This is actually given on the air test, sine, cosine, and tangent. In this case, I have this angle is 58. That's the angle of elevation. This is given as 20, and I want the height of this thing. So I want the opposite. If I want opposite and I have adjacent, ding, 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 that means use tangent. So tangent of 58 is opposite over adjacent. This is just one-step algebra, multiply by 20 and get 32. Pretty much this is their thought process. They say, hey, 1 and 2 are linear pairs, so they add up to 180. 3 and 2 are linear pairs, and they add up to 180. So, but if 1 and 2 add up to 180, and 3 and 2 add up to 180, then doesn't 1 and 2 have to equal 3 and 2? And then that sets you up to say that 1 and 3 are actually congruent. Okay, that would be the next actual step if you wanted to show that. All right. If we look at this, to show that things are independent, meaning they don't have anything to do with each other. So if you look at the probability of A occurring, it's 1/2. If you look at the probability of A occurring given C, it's still 1/2. So if I say what's the probability is everyone's wearing a green shirt and it's 1/2. And I say, well, what's the probability of someone wearing a green shirt given they're a boy and it's still 1/2, that means they have nothing to do with each other, right? Okay? Nothing to do with each other. Kind of like a better example of nothing to do with each other would be like flipping a coin and then drawing a blue marble, or drawing a blue marble and spinning a spinner and having it land on purple. Those events have nothing to do with each other. Or even just flipping two heads in a row. Neither of them have anything to do with each other. So if you know that the probability of A given C is identical to the probability of A, then it didn't actually matter that you were given C. So that means they're independent of each other, which means that probability of A equals the probability of A given C. All right, this is asking you to find the area of this little sector. Remember, the shaded area is a sector. The sector area is some fraction of the total area, and this was the formula we talked about in class. The total area is pi r squared, and some fraction of it is the sector area. And so that's exactly what this formula says. 45 degrees is the angle over 360 times r squared pi. Really, it should be pi r squared, but they just put the pi at the end. This is kind of like reading that Venn diagram with probabilities. They do tell you that 11 people speak Spanish. So everything in the Spanish circle has to be 12. And you know that's 5, that's 3, that's 1. So that little question mark, it's got to be 2. And that's what they really want. How many people speak both French and Spanish, but not German? So you're in the French circle and the Spanish circle, but not in the German circle. That's that red mark. And that ends up being 2. Remember, angle proves similarity. If you know two triangles have the same two angles, well, then they have to have the third angle the same, because the angles have to add up to 180. And once you know that, then you know they have to be similar. Angle proves similarity. Again, it does not prove congruence. It proves angles are similar, which means they have the same angles and their sides are proportional. All right, rigid. A rigid motion means you create a congruent shape. So you can reflect something, you can rotate something, you can translate something. All of those form congruent shapes. If you dilate something, meaning you blow it up or shrink it, those are similar shapes, but they're not actually identical. Remember, a congruent shape has the identical sides and angles. So two congruent shapes have the angles have the same measure, and corresponding sides have the same length. Literally, they're the same. Okay, so we take this quadrilateral, and again, I just drew a random quadrilateral, and then I moved it, right? It says it's going to translate it x over and y up. So I just went, and I moved this random quadrilateral I drew up here. And it wants to know the line segments, P, P prime, Q, Q prime. Remember, all of these are the original letters, right? S, R, Q, P maybe, and then this is S prime, R prime, Q prime, P prime. And it wants to know about these line segments. And so I just drew an example. I drew S prime is that red, and then the other three corresponding reds. But then look at each red. Each point went up and over the same amount. So that means each red line has to be the same slope, which means each line has to be parallel. And the only way they would be collinear is if the two lines themselves were already like aligned. And so if like S was here and P was here, then they both would have moved along the same line. So on my example, they're all parallel, but they actually could be collinear. Okay, which ones is similar, dude? You just got to find two of their same angles. 50 and 74, 50 and 74. Those are similar for sure. Ooh. 50 and 74. Yeah, those are similar. Those are similar for sure, right? There's just this, again, the scale factor would be 15 over 14, right? Angle proves similarity. Okay, you're not trying to prove these guys congruent. You're trying to prove them similar. Two angles. Density. I don't know why density is in this geometry thing, but I guess because we do area and volume, you can talk about density. But this question is in a lot, and density is very easy, right? Density is just mass over volume, at least the density they are typically referred to. So you just take the mass and divide by the volume on your calculator and just make sure you round it correctly. In this case, it works out perfectly to 11.34. 12's over here. Okay, so we know that the area of the volume of any prism is the area of some base times its height. we typically do length times width times height, but length times width is area. So it's really the volume of a prism, because it could be a rectangular prism, it could be a hexagonal prism, it could be a trapezoidal prism. We know that the volume is the area of that one face times height, or the volume of a cylinder is pi r squared times h. So in this particular case, they want the height to be 4 of this cylinder. So then the height of our prism is going to be 4, which means the quote base is the 3/6. So the base of our prism is 3/6 and the height would be 4. And so really what I just did is I just set those equal to each other. They said they want, for these volumes to be equal, I need the area of the base to equal the area of the base of the cylinder, which is pi r squared. So I set A equal to pi r squared. The area of the base is 3 times 6. So then I just 18 equal to pi r squared. And algebraically, to solve this, I just divided by pi and hit enter. And then I took a square root and got 2.39. You actually could put this into Desmos too if you wanted to. Right? Desmos can handle that, and they could have done it. And that's it. So, they don't release all the questions, but, certainly area and volume, triangles, angles, probability, circles, SOHCAHTOA, Pythagorean theorem, different shapes are kind of all on there. But this was the two 2024 released items. Hopefully this video helps.